When studying physics, it's important to focus on something you have an intuitive grasp of, at least at the beginning, before you dive into the more esoteric concepts of like fundamental forces. To that end, we're going to talk about the types of forces you might encounter in your day-to-day life. These types of forces are split into two broad categories: non-contact forces and contact forces. Non-contact forces are any force that can act at a distance. Probably the most familiar of these non-contact forces is the gravitational force, which is the attraction between masses. The equation for the gravitational force we will get to later on, but it is a universal gravitational constant times the mass of one object times the mass of a second object, all divided by the square of the distance between the two objects. A simplified version of the gravitational force when dealing with anything going on around the surface of a planet we call the weight force. The weight force is just the pull downwards due to gravity when you're at the surface of the planet, and that is equal to mass times little g. Notice that the weight force is a vector, and it is a force, whereas mass is a scalar, and it's just measurement of the inertia. So weight force and mass are not the same thing, even though we may say they and use the terms interchangeably when we talk in our day-to-day lives. The next most common force that is a non-contact force and acts at a distance is the Coulomb Force. This is either the attraction between opposite charges or the repulsion between like charges. We'll discuss the Coulomb Force in detail later on in the year, but the formula is very similar to the gravitational. There is a proportionality constant, charge 1 times charge 2, all divided by the square of the distance between them. The last non-contact force you're likely to encounter you might have seen in your kitchen, and that is the magnetic force. And this is the attraction or repulsion between magnets, or between magnets and a magnetic material like metal. The other broad category of forces you'll encounter are what we like to call contact forces, and these act at close range when two objects are touching each other. Technically speaking, contact forces that you encounter in your day-to-day life are just an expression of the electromagnetic force, which is a fundamental force. But it can be confusing to refer to all these different expressions of the electromagnetic force, so we'll stick to macroscopic definitions of forces for now, where we talk about forces we can have an intuitive grasp over. One of the most common forces that you'll encounter is what is referred to by physicists as a normal force. And here normal means perpendicular to the surface. This is a push that any object touching another object causes. We will use a capital N in this class to indicate normal forces. Make sure the vector is on top so you know that it's a force. Now the normal force is what's keeping you from falling through the floor or through the chair you might be sitting on. In reality, it is the electrostatic repulsion of the electrons in this chair and your own electrons that don't like to be near each other, that are pushing against each other. And that is what prevents you from falling through the floor or the chair. But that is complicated, so we just like to think of it as the chair pushing up with a normal force against the person. The opposite of a normal force would be a pulling force. For most of the problems we will encounter, a pulling force will be a tension force, or a pull from an object such as a rope. We will use a capital T with a vector symbol for tension forces. Another commonly encountered force is a friction force. These are retarding forces resulting from two objects trying to slide past each other. They act in the opposite direction of the motion, and thus act to slow down an object. It is in truth friction forces that make the first law non-intuitive for most people. Friction forces do come in two varieties. There is sliding or kinetic friction, and then there is the friction that prevents things from sliding in the first place, and that is called static friction. They have similar formulae, but are subtly different, and we will spend more time talking about these in the future. Another commonly encountered force is the spring force, sometimes referred to as Hooke's law, and this is a restorative force. Restorative meaning it tries to bring things back to where they were at the beginning. Essentially, the strength of a spring depends on a spring constant, which is partly due to what it's made out of and how tightly wound it is, and delta D, how far you actually stretch or compress the spring. We will discuss these a lot more in detail in a later unit. There is a number of other forces you might encounter in your studies. Though we will not go into too much detail of these, they may pop up occasionally in a problem. One of these is lift, which is what allows airplanes and helicopters to fly. Lift is essentially a normal force between moving air molecules and the wing of the plane. A similar force to lift is drag, and this is a friction-like force between a moving fluid, could be air or water, and the molecules of the object. This acts to slow down an object. One other force you may have heard of is the buoyant force. This is essentially the net effect of all the normal forces from the molecules of a liquid against an object. A buoyant force is what can hold a ship above water.